Okay, a few key facts about position graphs or x versus t graphs. Both terms are used. So we need to know that the points on a position versus time graph tell us where an object is at. So it actually does tell us the position of the object. If you are looking at the slope of this graph, because the slope would be the rise over the run is in meters, the run is in seconds, and so rise over run, meters over seconds, meters per second, that's the velocity. Use the units to help you decide what your calculation means. If you see a straight line, meaning just a graph like this on an x versus t graph, that means that you are moving at a constant velocity. So the velocity is not changing. If you see a horizontal line, something like this, that means that the object is not moving. It's staying at rest, or its velocity is 0. If you see a curve, more like the graph down below, something more like this, that indicates that the object is accelerating, meaning its velocity is not constant. It could be that it is losing speed or gaining speed, but it definitely is not constant. Now, how do you find displacement on this sort of a graph? Well, what you need to do is to look at the final position of something and the initial position or the earlier position of something. So let's say I was looking at the time interval from t equals 2 seconds to t equals 8 seconds. All right, so I would look for those 2 points on my graph. This is 2 seconds, and this is at 8 seconds. And I would take the later value first. So I'm going to estimate that's about a little more than 6. Let's call it 6.5 meters. And then I'm going to look to see where it was at 2 seconds. That looks to be exactly at 2 meters. So I would subtract those 2 values, and that would tell me the displacement of this object during that time interval. If I wanted to find the constant or the average velocity, then really I just want to take those 2 values and connect them with a straight line, and I want to find the slope of that line. And so the rise is exactly what we found before. That's the 4.5 meters. And the run would be the amount of time it took. So average velocity on an x versus t graph is going to be your change in your x values over your change in your t values, meaning change the rise over the run. And so we would take 4.5 meters and we would divide by how much this took, so 6 seconds, and we'd get a value of about 0.75 meters per second. Now if I want to find the instantaneous velocity, you can't have 2 different points. An instantaneous velocity is going to be at just one value. So let's say I wanted to find my instantaneous velocity at t equals 4 seconds. All right, so if that's the case, I would look at this position of, or this time of 4 seconds, and I would draw a tangent line at that point. Okay, so I'd grab a ruler, and I would draw a line that is just touching at that single point, and then I have to try to find the slope of that particular line. So maybe I would look at this point here. This looks like it has the coordinates of 5, 9. And maybe I'd look at this original point that I had in blue that has coordinates 4, 6. And so I would do the change in my vertical part, my delta x values. So 9 minus 6 is 3 meters. And then I look at my change in my horizontal values or my time values. That's just 1 second. And so my instantaneous velocity is a positive 3 meters per second.